In this video, we're going to review another concept that we learned a while ago, which is areas between curves. Alright, so what did we learn? We learned if we had these two curves, let's just draw an example. We have this one going like this, and maybe this one coming like that. Alright, there's some area between them. Alright, how do we find the area? Well, area is related to our integrals. And basically you find the big area of this blue graph. Alright, so that's taking the area of this top function, and you subtract away the area you don't want, which is the area under the red graph, which would be the bottom function. So you just kind of take more area than you want, subtract off what you don't want, and that gives you the area that you actually do want. So it's the integral of the top minus the bottom, and then A and B are just where these intersections happen. Alright, so you know where to start and where to stop. Alright, so I'm going to find the area between sine of x and cosine of x over the interval 0 to pi. So let's think about what that graph is going to look like. Alright, sine of x looks like this, and cosine of x looks like this. Then we find the area between 0 and pi. So there's this area, oops, let me use a different color. This area and this area. All right, up until pi. All right, so what is this going to be? Well, we're going to separate our integral. When do these two things hit each other? When is sine equal to cosine? That's at that 45-degree angle, pi over 4. So this happens at pi over 4. And for this first part, blue's on the top and green's on the bottom. So from 0 to pi over 4, we have to do the top function cosine minus the bottom function sine. So that's the integral that represents this first area over here. The second area is now going to be from, again, picking up where that one left off at pi over 4, oops, plus. And it ends when we are told to end at pi. All right, it keeps, the area kind of keeps going, but we're told to end it at pi. And in this case, the green's on top, that's sine of x minus cosine of x. All right, so sometimes when there's multiple intersection points, we have to write two different integrals because we're always doing the top minus the bottom. You can see the colors of the top switch at that pi over 4 place. And this is actually one you could solve by hand. You can do all these antiderivatives, plug in stuff. Just for the length of the video. All right, the setting up of the integral is the most important part. I find the area in the first quadrant. So first quadrant, I just know it's kind of this like top right part, 7x minus x squared. That's an upside down parabola. I'm not exactly sure what it looks like, but I know because it's got the minus x squared, it's an upside down parabola. So it looks something like this. And the line y equals 10. I could, again, I'm not 100% sure what this looks like by just looking at the equation. I can make it more accurate by doing more work, but I'm pretty sure it's not going to be up here because then there wouldn't be any area. I'm pretty sure y equals 10 is going to be somewhere like that, and we're trying to find this area that starts at 0 and ends at 5. So our integral is going to be 0 to 5. The top function is going to be the quadratic, and then we subtract off the bottom function, which is just the line 10. So that's our integral. Again, this one you could definitely simplify a bit. Negative x squared plus 7x minus 10. You could take the antiderivatives. Evaluate it from 0 to 5. Plug in 5 first, subtract, plug in 0, and you get your answer. All right, so this one, not too bad to actually do the whole process, but again, we're not going to spend time just plugging in values. All right, here's one for you to try on your own. I find the area in the first quadrant, found y equals 4 minus 3x, and y equals 1 over x. All right, so take a second, pause the video, and try that one on your own, and then I'll show you the answer in a second. All right, so 4 minus 3x is going to be a line downward, 1 over x. Oops, use a different color. Looks like that, and you can see this area here. All right, so this one I actually made it a little bit harder for you guys because we don't know where it stops and starts, so we need to find when these things are equal. All right, so to do this, I would multiply both sides by x 3x squared minus 4x plus 1 equals 0. Positive 3, negative 4. I'm just trying to factor this now. I'm trying to do it as quickly as possible so I don't spend too much time. Alright, so if you break this down, you can do the quadratic formula too. If you break it down, you get x equals 1/3 would be where the first intersection happens, and 1 is where the second intersection happens. So our final integral, 1/3 to 1. The top function is the line. The bottom function is 1/x. And again, you could anti-differentiate this. I'll just show you real quick because this one would be 4x minus 3/2 x squared minus natural log of x. So this is one of those times where it seems like all these are reverse power rules, but because the 1/x is the different one, I'd have to do something like this to get your final answer. All right, so just a quick review of areas between curves, just remembering how to set up those things, how to find the intersection points, all that stuff. Simplify before taking antiderivative. We didn't do like the full antiderivative, the whole process in the video, just to keep it a little bit shorter. But most of those last few steps is just plugging in values and simplifying.